Today we will be discussing about unit 2.5, that is covering mounting structures. So PV mounting systems, they are also known as solar module racking. So these are utilized to get the solar panels attached to locations. So some specific locations are like the rooftop, exterior of building, or even on the ground. For large scale solar panels, they are installed on the ground. So retrofitting of these solar panels on roof in a section of building. In brief, we call it as BIPV. So can be done with the help of mounting structures. Now we will cover the importance of mounting structures. First of all, to avoid local wind forces, so it should be strong enough. That wind should not distort or disorient this our solar panels or the entire structures. So it should be strong enough. Okay, it should be strong enough to hold the PV modules securely in a place. Another importance is to prevent stealing of the modules when placed in public area, because the theft, that is also a big problem here. So our mounting structure will prevent the stealing. To ensure the modules are not shaded, this thing we have to observe, because if we place the solar panels in shading, then the generated power will be very less. So to maximize the power generation, to make our system efficient, we have to place it the panels in a area where shading is not there. Okay, next importance is to enhance easy access for maintenance or repair of modules. Because maybe timely we may be needing maintenance. Cleaning is a very common type of task to be done regularly, because dust that accumulates on the surface and that reduces the power generated by the PV panel. Okay, then further some repairing or some other small maintenance. For that, easily we can access these modules. And then the special mounting structures that can serve as PV modules as well as building elements are developed for integration in buildings. Okay, so special structures, they are available for mounting in buildings. Okay, in the facade means the front, the exterior of the building, there we can install the solar panels. On warning sign boards, there we can install outdoor lighting. Outdoor lighting is there on the same pole. On the top of that, we can, on top or anywhere in the suitable location, we can mount the solar panel. Similarly, telephone box roof, that is also a common place where we can mount our solar panel. Now, one more thing is the cost. The cost of this structure, that should also be low, so as to make it economically feasible. The solar panel. Okay, so this is one of the limiting constraint, the cost of the mounting structure, because the total energy generated, the cost of that energy will be increased due to the cost of mounting structure. So type of mounting structure, so some very common type of mounting structures, and mainly the metal which is being used, that is aluminum or galvanized iron or mild steel. So these are most commonly used materials or metals for the this mounting structure. So basic solar panel mounting systems are shown here, these four types. First one, ground mounting. So large scale solar plants, solar PV plants, they are using ground mounting. So land area is there, and these type of panels, they are mounted on the ground. Another one is the roof mounting. Okay, on the roof, these panels, they have been placed here. Third one is shade structure mount, very common for parking areas, and it is mostly implemented especially in the parking of the government institutions. There we can find it. Okay, so these are working as a shade. Okay, on the top of the shade there is the solar panel, and below that the parking vehicles are being parked there. Okay, next one is building integrated photovoltaic, BIPV. So they are now integrated on the roof. Okay, like on the roof mounting, they were mounted over the roof. Roof material was there. Proper roof was there. After that, we mounted the roof panels on the roof. In this case, in building integrated, these panels are integrated on the rooftop. The material on the rooftop that is not there. Instead of that, the solar panels are there. So some of the commonly used PV array mounting systems, they are shown one by one. Ground mounted PV array. So they are used for large PV systems or where the rooftop installations are not practical. There we use it on ground. So they can use rack, pole, and other foundation for supporting the arrays. Then they are usually more vulnerable to damage than rooftop arrays. But the constraints for their orientation and location is less as compared to the rooftop installation base, because on the ground freely we can orient it in any direction, we can place it as per our requirement. On the rooftop we are having the limitation, we cannot place it anywhere, limited area is there. So in that case it is having an advantage, but they are mounted on the ground, so the cause of damage could be more because access is very much here. Next one, integrated mount. So these panels are directly attached to rafters and replace roofing material. I mean, the roofing material is not there. Instead of that, panels are there on the rooftop. So that's why it is integrated. So they require modules that are integrated into the exterior of the building. Okay, or roofing. Sometimes these systems are referred to building integrated photovoltaic. Means they are integrated on the outer material of a building. Next is stand-off mount or flush mount. So they use stand-off to the roof for supporting rails on which the PV modules are attached. So stand out on which we stand. We will see some in the later units when we are studying about the installation process, how to access. So there we can see the standoffs. So they are placed on that. We are placing the solar panels on the top. Means roof that is as per the normal the roof is placed. Material is there. On that we are placing the panels. So they allow sufficient gap to provide airflow, as solar panels usually need air to give best performance. Yes, temperature that should be maintained. We have already studied it in our previous units of solar PV systems. So they are recommended and popular mounts for residential purpose. Yes, so most commonly on the rooftop, this type of installation is available. Standard panel fixture. So this they allow panels to be fixed in the customer place as it is. Okay, so there is no requirement of adjustment in these fixtures. Now on the other side, non-standard panel fixtures. Okay, so they require pictorial representation of customer place where the panel is to be placed, installed. Okay, so separate pictorial representation is there, separate designing is there, especially for the specific customer rooftop model. The type is ballasted mounting system. So they are used in flat roof commercial projects. Yes, so inclined, they are not using this type of project. On the flat roof, there we can use it. So they are dependent on the weight of the array. Okay, racking system and materials such as concrete paver to fix the array to the roof or the ground. Okay, so these are the requirements. Racking system is needed. Okay, concrete paver that is needed because you have to fix it. So they do not require penetration to roof or the ground. And the rooftop type, popular one, the rooftop system which is to be installed. So they offer less physical protection and limited access to the PV array for safety. Means easily we cannot go to the roof and access the point there. Okay, that reason is for the safety purpose. So sun exposure, that is good in this case. They are on the rooftop. So they do not occupy space on the ground. Okay, so that is a advantage, that it is not requiring the ground area. Already existing infrastructure it is using. So that is better from the economical point of view as well. Efficiency is also increased. In the way, the economic efficiency. Okay, so they must be secured structurally and any attachment and penetration must be weather sealed properly. Yes, because access is not frequent. So it should be properly sealed from the natural calamities or the unfavorable weather conditions. Because the shading we have to check. Shading is not coming there. direct mount. They allow panels to be directly attached to the rooftop, like they're in the shown in the diagram. Directly they are attached to the rooftop, so they are very easy and cheap. Pole mounted, just as we discussed, that is in the case for some lighting or pole used for lighting or some other type of a signboard. So there we can use this type of mountings. So they are generally used with manufactured racks that are mounted on the top or attached to the side of a steel pole. So they are popular for off-grid residential photovoltaic systems. Okay, off-grid applications, they are most popular. So weight of the PV array is balanced over the pole, and seasonal adjustment can be done easily. Okay, maybe we want to tilt it in the direction because of the sun. They are very common in small applications having one or two modules. Yes, because large modules we cannot implement on the pole. Physical constants are there. So small installations, they are very much better scope to install the smaller sized modules. Yeah, cooling, that is very good in this case. Because the rooftop the space is less. Here the space is also there, and freely the wind is going through this panel, so cooling is there. Rack mounting structures next. So they are used for non-tracking system at ground level. Okay, at the ground we are using it for large scale plants. Usually they are built on the ground. This one, technically advanced, has to get better production, electricity production. So they sun tracker systems. The name indicates they're tracking the position of the sun. Yes, so they will change their position as the sun changes from east to west. They will also move. The direction will also change. So we need a proper tracking system. Okay, so they are generally mounted on poles and allow the system to receive greater amount of solar energy. So they can allow tracking to enhance the summer gain by 30% or more, but in winter it is less than 15%. Yes, obviously the generation will increase because every time it is facing, because in the unit of this PV system, when we studied that this factor is directly affecting the angle which is inclined, at which our panel is inclined, that directly affects the electricity produced. So here we can maximize, we can maintain the same angle for maximum production. So they allow tracking in two axes to achieve maximum performance. There's two axes, east to west we can say, north to south we can say. So seasonal and daily, for every type of position of the sun they can adjust. Okay, single axes are also there, means only north to south, east to west we can use for to track the daily position of the sun. Shade structure, which I just referred as most common in the case of a parking system. So parking is there. So they are working as the shades. Solar PV panels, they are working as shades, and below these the vehicles are parked. So two purposes are solved. Shading for parking, that is being provided, and electricity, that is also being generated. So two questions for activity you can try.